Hi everyone. So this video is going to begin our review and supplement of Module 4A, which provides a discussion of the scientific study of problem solving. All right, so in this particular video, I'm going to talk about one of the phenomena that you read about in the textbook, and that is functional fixedness. Okay, so let's go ahead and get started. Well, the definition that they come up with is a problem occurs whenever there is an obstacle between your current state and where you want to end up, or your goal state, right? So there's an obstacle between where you are now and where you want to be, and it's not immediately obvious the steps you should take to get around that obstacle, right? So in problem solving, we're trying to progress from our current state or present state to a goal state. And in order to do that, we have to figure out how to get around an obstacle. So research by psychological scientists investigating problem solving has focused on basically two different objectives, right? So the first objective is simply to study the mental processes that occur as a person is attempting to solve a problem, right? So what are the underlying cognitions that are part of problem solving? And the second one is very similar to research in the field of learning and memory, right, where psychologists work with textbook companies and teachers and professors to optimize their instruction. Psychologists specializing in problem solving often attempt to come up with kind of interventions or strategies people can use to make problem solving easier and more effective. Okay, so that's what we're going to focus on today is what are the underlying cognitions associated with problem solving and how do we optimize problem solving? Okay, so the structure of this lecture is going to be very similar to the structure of our lecture on judgment and decision making, right? So just like before when I gave you guys different activities that I wanted you to solve in a worksheet, I've done the same thing for this module. So there's 3 different activities for you guys to do. And each of those activities corresponds to a particular, in this case, a particular problem that psychologists have studied in the laboratory, right? So if you haven't done so already, please go ahead and pause the video and go back and download the activity sheet from Canvas and go ahead and complete those 3 activities. Again, I'm not going to collect them for a grade, but I think it'll be a lot easier for you to understand things going forward if you've tried to solve those activities yourself. Okay? All right. So the first activity I asked you guys to do, or the first problem I asked you guys to attempt to solve, is something called the candle problem. The candle problem. So this particular problem asks you to imagine that you are led to a room that contains a table. And on that table there are 3 objects: a candle, a box of matches, and a box of thumbtacks. Your task is to find a way to attach the candle to the wall of the room so that it burns properly using no other objects than those on the table. Right? So what solutions did you guys come up with when you tried this activity yourself? Well, some of the most common solutions I get from students is maybe they try to melt the candle, right? And then the melted wax has some kind of adhesive or gluey texture, right, that sticks the candle to the wall. Okay? So that's the most common solution that I get from students, but that's actually not the answer. So let's go ahead and explore what the answer to this problem is. Okay. So the solution to this problem occurs when a person realizes that the matchbox can actually be used as a support rather than a container, right? So what you can do is you can dump out the matches of them and use the matchbox, right? And use the tacks to affix the matchbox to the wall, right? And that effectively is used as a shelf to hold up the candle, right? So why are psychologists interested in studying this particular problem? Well, to answer that question, I'm first going to tell you about two different experiments that were conducted using this problem as the basic task that participants solved. Okay? So in one experiment, this problem was presented to a group of participants, and when they received the materials, they were given small cardboard boxes containing each of the items. So they received a small cardboard box full of candles, a small box full of tacks, and a small box full of matches, right? So in that case, these boxes were clearly being used as containers for items, right? But then another group of participants were asked to solve this same problem, but in that case, they were given the same materials, right? So they were given the matches and the candles and the tacks, but they were outside of the boxes, right? So they received candles, matches, and tacks, and then 3 empty boxes. And what the researcher found is that when he compared the performance on this particular problem between those two groups, he found that the group that had been presented with the boxes being used as containers found the problem much more difficult to solve than the group that was presented with the empty boxes, right? And then this was replicated actually in 1952 by Robert Adamson. So he repeated the original experiment and got the same exact results. So when participants were presented with the empty boxes before solving the problem, they were twice as likely to solve the problem effectively than participants that had been presented with the items in containers. So again, before we talk about why this is interesting, I'm going to present you guys with one more problem. So this is called the 2-string problem, right? So basically, your objective in this problem, right, is you're given a chair and a pair of pliers, and using just those items, you need to tie these 2 strings together, right? But inevitably, what you notice if you try to solve this problem is that the strings are too far apart, right? So what happens is you end up reaching for one of the strings, and then your arm isn't long enough to reach the other one, right? So how do you solve this problem? Well, to solve this problem, participants need to tie the pliers to one of the strings and create a pendulum, which can then be used to swing the other string within the person's reach, right? So two things are particularly significant about the two-string problem. First, 60% of participants who are given this problem did not solve it effectively. And the reason is because they're too focused on the typical function of pliers, which is to, grab things and twist them rather than functioning as a weight. Right? The second thing to notice is that when Meyer, 1931, took another group of participants and asked them to solve the problem, right? Instead of just leaving them to their own devices, this researcher tapped one of the strings so that it started swinging back and forth. And when the researcher did that, 23 out of 37 participants who hadn't solved the problem after 10 minutes, right, suddenly were able to solve it in 60 seconds, right? So seeing the string swinging from side to side apparently triggered the insight that pliers can be used as a weight to serve as a pendulum that creates that swinging motion. So what does this mean? What do the candle problem and the two strings problem have in common, and why are they interesting to psychologists? Well, the reason is because they both illustrate something called functional fixedness. Okay, so functional fixedness is the tendency to think about objects in terms of their typical or customary uses, right? So both the two strings problem and the candle problem require you to use these objects in an unconventional way, right? So in the candle problem, instead of using the box of matches as a container for matches, you're instead using it as a shelf or a support for the candle, right? And in the two strings problem, you're using the pliers as a weight or pendulum rather than to twist or pick up objects, right? So what makes these problems so difficult to solve by themselves, right, is that particularly in the first case of the candle problem, where you're given the 3 boxes of the materials, right, is you're led to think about the objects as you would normally interact with them, right? And that prominent response or that prior experience is almost going to have a blocking, right, or interfering effect, right? Because those typical uses are going to become very prominent in your mind, right? You have a lot of experience using those objects in the typical ways. So trying to think outside the box, so to speak, and come up with a more creative and atypical use of them, right, is going to be much more difficult. Much more difficult than it would be if you didn't have any prior experience with that object. So one thing I wanted to illustrate here is that even though we all experience functional fixedness, and we all have a lot of difficulty with the candle problem and the two strings problem unless we know the answer beforehand, right? So we all experience that blocking or fixation from prior experience. It is possible to overcome it. So it is possible to think about objects in a creative way. So this is actually kind of an internet sensation. So I went ahead and posted a viral video for you guys in the slides. So if you haven't already, please check it out. So in this particular video, it's just kind of a mashup or a compilation of videos of people coming up with kind of silly, crazy things you can do with everyday objects, right? So it's an illustration of overcoming functional fixedness, and it's kind of funny. So go ahead and check that out. And the other example I wanted to give you of overcoming functional fixedness is a personal example of mine. As I think some of you know, I have a disability. So the disability that I have is cerebral palsy. And basically there are many different subtypes of this particular disability. But the kind that I have basically creates or is caused by what's called muscular spasticity, right? So what spasticity refers to is just having muscles that are very, very tight, or having muscles that are contracted all the time, right? So it's very, very difficult for individuals like myself with this condition to relax their muscles, right? And so what happens as a result of this disorder is you can develop what are called contractures, which are basically the permanent shortening of muscles, right? So your muscles literally start to shrink because they've been so contracted or so tight all the time. And so one of the ways that they treat muscular spasticity, particularly in children, is that they do surgeries called muscle lengthening surgeries. So with muscle lengthening surgeries, they literally open you up and take those shortened or contracted muscles and stretch them surgically, right? And if you're a child with cerebral palsy, you might have this done 2 or 3 times in your childhood, right? So that was the case with me. I had it done about 3 or 4 times. And each time that I had it done, I had to wear these leg casts for about 6 to 8 weeks. So you might imagine that that's kind of a challenge for a young kid that likes to run around and do stuff. And one of my favorite activities at that time in my life was I really liked to listen to country music. So I liked, Garth Brooks and Faith Hill and all those folks that you guys probably don't even remember. Or you weren't even born yet when they were really famous. But and so obviously this was in the 90s. So I didn't have like an MP3 player or anything like that. So I had to actually listen to what they call a boombox, which is this big monstrosity that has a cassette player and a CD player and a radio in it. And one of the things that I would have to do is my boombox would only work if the lights in my room were turned on. So one morning I was sitting on my bed and I wanted to listen to my CDs, and I had to turn my light switch on, right? But the light switch was all the way across the room and I couldn't stand up to turn my light switch on. So what I ended up doing is crawling kind of on my stomach across the room. So I got to where the light switch was, but I still wasn't tall enough to actually turn the light switch on. So I started sort of looking around my room, looking for something that I could use to kind of, prop that light switch up. So I started to look for like a stick or something long to use, but I noticed I didn't have anything like that. But what I did have is I had a box of Crayola markers sitting on my little art table. So I went over to my box of Crayola markers, and one thing you guys might remember about Crayola markers is they all fit kind of into each other, right? You can stack them on top of each other, right? So that's what I did. I stacked all of my markers on top of each other and basically created a giant stick out of the markers, and I used it to turn the light switch on, right? So that's kind of a long-winded example, but it illustrates that this is something we have the capacity to do, right? It might not be our first response, and like I said, there's going to be some blocking or interference because of our prior experience with those typical uses. But that experience can be overcome, and we can actually generate creative solutions if we're ever put in a situation where it's adaptive to do so, right? So obviously in the laboratory, people aren't going to be particularly motivated when solving kind of an abstract problem. But the truth is that in the real world, right, in vivo, all of us are occasionally faced with situations where we have to use objects in an atypical or not customary way. And we all have the ability to do that,